So I hope everyone enjoyed the first video in this installment that covered the hardware build portion of the Delta5 Race Timer. In this segment, I'm going to cover the cabling, or how to wire up the Delta5 Race Timer, and also we're going to cover the Arduino software installation and configuration. So here we're going to use the 5-volt regulator to power the Arduinos and the Raspberry Pi. So with the 5-volt regulator, we'll be powering off of pin 4, which you can see in the diagram here, and the ground would go to pin 6. So I'm going to take a servo cable. We use the positive and the negative, but we do not use the white cable or signal, as shown here. So I'll go ahead and I'll take the positive and make sure it's on pin 4, and the negative, which would go on pin 6. The white cable or signal is not utilized, so you can just ignore it. And then we're going to connect SCL and SDA, and we're going to use the same color coding. And here you can see SDA is on pin 3 and SCL is on pin 5. So again, we'll use the positive and negative as indicators, and we'll go ahead and put them here side by side. And you can see them here on pin 3 and 5. So the 3-volt regulators power the VRX modules, and we can put all the boards in a line here, and we can daisy chain them together, or you can connect a single board just for a 4-pilot system. So here you can see how I'm going to pass the power from board to board over to the Raspberry Pi. So these connect right across one another, directly across. So, ground to ground, positive to positive, SCL to SCL, SDA to SDA, and then the bottom row of pins as well, ground to ground, positive to positive. And you can see me here wiring these up. So here I have a 6-pilot system. This can be expanded to an additional 2 pilots, and it could be a complete 8-pilot system. And you'll see a pin here on the bottom right hand corner. It's a 5-volt pin. And what I'm planning on putting here is a fan to keep the system cool in the case. So I'll probably use active cooling and passive cooling. This is a Noctua 5-volt fan. Very efficient. It's got a positive and negative. So I'll just locate that here in the connector, and I'll go ahead and connect it. And that would be it for the 5-volt fan. So here you can see the entire system, how it would be cabled up. And I'll connect power here, and you can see all the Arduinos are powered. You can see my fan is also powered up and spinning. And you can see the light on the Raspberry Pi up here in the top corner. So the entire system is running. So here I'm going to go ahead and remove the jumpers, and this is so you're not powering the Arduinos by both battery power and by USB power, which lead them to be damaged. So I'm just doing it as a precautionary measure. Even though I don't have them connected to LiPo power, I'm just prepping them for the software configuration portion. So here we're going to visit the Arduino site, the software section, and downloads. And here we want to grab the latest version of the Arduino IDE for our specific operating system. Mine is Mac OS, and I went ahead and installed this already. Then we go over to GitHub and visit the Delta5 Race Timer site, and we can download the latest zip file. We'll go ahead and download it to our local machine, and we can go ahead and extract that. And we unzip it here, and we can go into the Delta Race Timer folder, and then into the source folder, and then into the Delta5 node. So here you can see the Delta5 node.ino. We'll open that, and you can see Arduino launching. So I'll go ahead and connect my first Arduino via USB while the program loads. And here you can see the program has loaded. So we're going to take a look here and locate the node number that we want. So node 1 equals 8 here. You can see that on the line. So we want to make sure that the first node that we're defining. So here under tools, I want to make sure I have Arduino selected, processor at Mega 328, and I want to make sure I'm using the serial connection. So here I just hit upload, and you can see here the lights on the Arduino are starting. In the bottom left hand corner of the screen, you can see it says uploading, and when the process is complete, it will say done uploading. So then we'll move on to the next node, which is node 2 equals 10. So we got to change this 8 to a 10. And we'll go ahead and disconnect from the first Arduino, connect the second, and we'll go up to the top of the page and hit the upload button. And here you can see the process of the Arduino. It's uploading. When that completes, it'll tell you that it's done uploading. So then we need to move on to node 3. Node 3 equals 12. So we'll change the slave address down here to 12. And you can see I unplugged the Arduino, plug in the next one, go up to the top of the page, click upload. You can see the lights on the Arduino change, so it indicates that there's activity. When that's finished uploading, we'll move on to the next node, 4. This is number 14, so we'll change the I2C slave address to 14. Go ahead and disconnect from node 3 and connect node 4 physically. Hit the upload button. Wait for that uploading procedure to finish. Once that's complete, we'll go ahead and disconnect, and we'll move on to the next board. Here we're going to go ahead and connect the next board, so this would be node 5. So I'll locate node 5, which equals 16. So we'll make sure that we change the slave address to 16 for node 5. Hit upload. You'll see the activity on the Arduino. Uploading. And then we'll go ahead and disconnect node 5, connect to node 6 in this case. Check node 6. Node 6 appears to be number 18. So you can see here, node 6, 18. So we'll change slave address to 18 and go ahead and hit upload. And it'll just take a few moments to upload, and you can see the activity. So once we get to the end of the process of the 6 nodes, you can continue with nodes 7 and 8 if you have a 8 pilot system. In my case, I'm finished with 6 nodes. We use IMD6C in our chapter, so we'll only fly 6 pilots typically at a time. If we need additional throughput, we can simply add a couple extra modules, and we can go ahead and run race band with all 8 pilots simultaneously if we need better throughput. But we're doing pretty good on IMD6C, so we'll leave it with 6 pilots. And that's the end of this video. Stay tuned for the next one.